All right, everybody, welcome back for another deep dive.
Yeah.
Today, we're looking at some pretty cool research.
Yeah, it's very interesting stuff.
It has to do with large language models, and those of you who follow the show
Right.
know that we've talked about LLMs a lot.
Yeah.
And for good reason.
Lots of potential there.
Absolutely. And this is really kind of pushing the boundaries of LLMs even further. So this research that we're looking at today is exploring how LLMs can be used to generate code.
Oh, wow.
But not just in any programming language.
Okay.
It's in those super niche programming languages that you rarely hear about. So, think about it.
Okay.
An AI assistant that can write code for you.
Okay.
Even in those languages that are specific to like one tiny little field.
Right.
And we're actually looking at two specific cases here.
Okay.
One is configuring metro wagons using a language called MiniZync.
Okay.
And then the second one is testing railway signaling systems with something called BTTL, or Belize Telegram Test Language.
Oh, very cool.
So these are very specialized languages.
Yes, very.
And the paper even says that they define these niche languages as languages that don't appear in something called the TIOBE index, which basically is like a popularity index for programming languages.
Right.
So if they're not in there, it means they're pretty niche.
Makes sense.
And, this is something that I think a lot of our listeners can relate to because the more specialized your field gets, the more likely you are to encounter this problem.
Yeah, you're going to be using some kind of unique language.
Exactly. So can you explain to us why exactly this is such a challenge?
So, LLMs, these large language models, they're trained on massive data sets of code.
Right.
But if they haven't seen much of a particular language during training, they're going to struggle to understand its nuances.
Makes sense. It's like if you only ever spoke English, and then someone suddenly asked you to write a poem in ancient Greek.
That's a great analogy.
Right. So what do you do? How do you solve that problem?
Well, the researchers in this paper came up with a pretty ingenious solution.
Okay.
They propose using something called a DSL.
A DSL.
Yeah, a domain-specific language.
Okay, now I'm sure some of our listeners are familiar with the term DSL.
Yeah.
But for those who aren't, can you explain it?
Sure. So basically, it acts as a kind of translator.
The translator.
Yeah, between the LLM and the niche language.
Okay.
So it takes the user's request, translates it into a format the LLM can understand, and then helps generate the final code in that target language.
So it's kind of like a go-between.
Exactly.
Making sure that everybody is on the same page.
Precisely.
Speaking the same language, so to speak.
Yeah, and what makes this approach particularly cool is that they decided to use a JSON-based DSL.
JSON.
Yeah, which is great.
Okay.
Because LLMs are already really good at understanding JSON.
Right.
It's a data format they see all the time on the web.
So you're kind of playing to the LLM's strengths?
Exactly. Giving it something it already knows how to work with.
Okay, so that's the familiarity aspect.
Yeah.
But are there any other advantages?
Absolutely.
Yeah.
So by using a DSL, you're also limiting the scope of what the LLM has to handle, which reduces errors and kind of keeps the AI on track.
Right, because we don't want our AI-powered metro wagon suddenly sprouting wings.
Exactly. You want it to stay focused on the task at hand.
Right.
And generate code that's accurate and tailored to that specific niche language.
I love it. So let's actually dive into that first example, that they talked about in the paper.
Yeah.
Configuring metro wagons using MiniZync.
Right, so MiniZync is a really interesting language.
Right.
It's great for defining constraints and relationships between different elements. Think about all the things you'd have to specify when designing a metro wagon. The number of seats, their color, the types of handrails, the passenger capacity.
Yeah, it sounds incredibly detailed.
It is. It's all about making sure all those pieces fit together perfectly.
So what kind of task did they give the LLM to work with?
So they gave it a request, like the wagon should accommodate more than 120 people.
Okay.
With room for 40 to sit and make those seats red.
So they basically gave it like a design brief.
I guess.
And said, go make this happen.
Exactly.
And I'm guessing the DSL came in handy here.
Absolutely. So the LLM used that DSL translator to understand the request and generate MiniZync code that met those requirements.
That's amazing. And how did they know if it actually worked?
Good question. So they compared the AI-generated code to code written by human experts in MiniZync.
Oh, that's clever. So it's like a benchmark.
Yes, exactly.
So what were the results?
The results were really impressive.
Okay.
Using the DSL led to a 16% improvement in accuracy.
16%?
Yeah, compared to just letting the LLM tackle MiniZync directly.
Yeah. Wow, that's significant. especially when you consider how complex it is to design something like a metro wagon.
It really highlights the potential of this approach.
It really does. And, it makes you wonder if this could be applied to other areas beyond just metro wagons.
Oh, absolutely.
Right? Like, what about designing airplanes, buildings, or even entire cities?
Yeah, the possibilities are really endless.
This research is really showcasing how powerful this combination of LLMs and DSLs can be for tackling these really complex real-world problems.
Yeah, and speaking of real-world applications, their second example focuses on something even more critical. Railway signaling systems.
Wow. So we're talking about systems that are essential for safety.
Absolutely. These signals control train speed, track switching, all sorts of things that are critical for preventing accidents.
So no pressure on the AI.
Right. Exactly. And for this example, they used a language called BTTL.
BTTL.
Yeah, which stands for Belize Telegram Test Language.
Okay, so what kind of challenge did they throw at the LLM for this one?
So the user request was focused on ensuring that level transitions, which are basically changes in the train's operating mode, only required level 1 or 2 authorization.
So it's a very specific safety check?
Yeah. It is.
That's crucial for preventing accidents.
Exactly.
And I'm guessing the DSL played a key role here as well.
Absolutely. It helped the LLM understand the nuances of BTTL and generate the correct code to perform this safety test.
Now, did they actually test this on a real system?
They did. They actually ran these tests on a real railway system.
Wow, that's next level commitment to research.
It is.
So what happened? Did it work?
The results were even more impressive than with the mini-zinc example.
Really?
Yeah, they saw a 26% improvement in accuracy when using the DSL.
26%?
Yeah, compared to not using it.
That's incredible. That's a massive improvement.
It is, especially when you're dealing with something as critical as safety.
Right.
So it really shows the potential of this approach.
It seems like this DSL approach is really unlocking the potential of LLMs to work with these niche languages.
It is. It's really exciting.
That were previously kind of out of reach.
Yeah, it's a game changer.
Think about all the complex systems out there that rely on these specialized languages, like air traffic control, power grids, financial markets.
Yeah, all sorts of things.
This research shows that we can actually use AI to not only understand but also generate code for these systems.
That's right.
It's potentially revolutionizing how we design, test, and maintain them.
It is. It's like having an AI expert on hand, ready to help you navigate all the intricacies.
Exactly. And this is just the tip of the iceberg. We've seen how LLMs can tackle mini-zinc and BTTL. But what other niche languages are out there? What other challenges could we solve if we had these AI assistants that could speak the language of these specialized systems?
That's a great question.
It is something to think about.
Yeah.
As we move into the next part of our deep dive, where we'll actually explore some of the limitations, future directions of this research.
Sounds good.
So stay tuned.
I'm excited.
Okay, so we've seen just how powerful this combination of LLMs and DSLs can be.
Yes, pretty remarkable.
But like with any emerging technology, I think it's important to look at both sides of the coin.
Yeah, absolutely.
The opportunities and the limitations.
For sure.
So in terms of limitations, what are some of the things that the researchers pointed out in this paper?
Well, one of the key challenges they highlighted was the size of their evaluation data sets.
Okay. So what do you mean by that?
Well, to really test the robustness of this approach, you'd ideally want tons of code in these niche languages. But that can be hard to come by.
Yeah, that makes sense.
It's like trying to learn a new language from just a handful of phrases. You might pick up a few things, but you're not going to be fluent.
You're not going to be able to have a full conversation.
Exactly. And that's kind of the situation here.
Okay, so it's like they were working with a limited sample size, which means that the results might not be generalizable to all situations.
Exactly. It's a good starting point, but more research is needed.
Oh, okay. What other limitations did they mention?
Another interesting thing they observed was the sensitivity of the system to the way the user phrased their request.
Okay, so how the user asks the question.
Yeah, even small changes in wording could lead to different code being generated.
So it's not just about giving the LLM data. It's about carefully crafting the instructions.
Exactly. You need to guide the learning process.
It's like you're teaching it how to think about the problem.
Yeah, That's a great way to put it.
So the human element is still very much present here.
Absolutely.
We're not just handing everything over to the AI and hoping for the best.
No, we're still shaping how it learns and what it produces.
And this brings up some really interesting questions about the future of programming.
Yeah, for sure.
Will we see a shift from writing code ourselves to becoming more like architects?
Okay.
Designing the blueprints.
Yeah.
And letting AI handle the construction.
It's an interesting thought, isn't it?
It is. Instead of spending hours, debugging code,
right.
Maybe we'll be spending more time designing elegant solutions.
Yeah.
And then refining the AI-generated code.
Exactly. Making sure it meets our exact specifications.
That's a whole new way of thinking about programming.
It is.
But of course, some people might be worried about this.
Right.
They might think that AI is going to replace human programmers altogether.
Yeah, that's a common concern.
Is this research a sign that coding is becoming an automated profession?
Well, I think it's important to remember that AI is a tool.
Okay.
It's not a replacement for human ingenuity and creativity.
Right. It's like a powerful new tool.
Exactly.
In a programmer's toolbox.
Yeah. Yeah. Just like the invention of the calculator didn't eliminate the need for mathematicians.
Right.
AI won't eliminate the need for programmers.
Okay.
It's going to change the nature of the work we do.
So this is just another step in the evolution of programming.
Exactly. As programmers, we've always had to adapt to new languages, frameworks, and tools.
This is just another chapter in that story.
Yeah, that's a great way to look at it.
So as we move forward in this world of increasingly sophisticated AI, what's the key takeaway?
I think the key takeaway is that AI is not here to replace us.
Okay.
It's here to empower us.
I like that.
We're entering an era of collaborative coding.
Collaborative coding.
Yeah, where humans and AI work together to build the systems of the future.
It's exciting, isn't it?
It is. It's an incredible time to be a programmer.
We have this amazing new technology at our disposal.
Yeah, and this research is just a glimpse of what's possible.
It's like we're breaking down the language barriers between humans and machines.
Yeah.
That's a great way to put it.
It's allowing us to collaborate on a whole new level.
And that opens up so many possibilities.
It really does. We've covered a lot of ground today.
Yeah, we have.
From the specifics of this research to the broader implications for the future of programming.
It's been a great discussion.
But before we wrap up, I want to take a moment to ponder the larger questions that this technology raises.
I'm ready.
What are your thoughts? It's interesting. We've talked about the technical details of this research and the potential benefits and even some of the limitations. But for me, it's the philosophical side of this that's really captivating.
It really is.
We often hear about AI automating tasks, making things faster, more efficient.
Sure.
But this research, it's showing that AI can also expand our horizons.
I agree.
It's like these LLMs are giving us a new way to understand these niche languages.
That one seemed completely inaccessible.
They were like a black box before.
Exactly. It's like we're deciphering a hidden code. Yeah. Unlocking this whole new realm of knowledge and possibilities.
And languages that were once, the domain of just a few specialists.
Right.
They're becoming more accessible now.
Right, because of AI.
Exactly.
It's really democratizing knowledge.
Yeah, it is.
Imagine a world where anyone, regardless of their background, could just delve into these specialized fields and contribute their ideas.
It's a powerful thought.
It is. And, this is just the beginning.
It is. We're just scratching the surface.
As AI continues to evolve, who knows what other doors will open?
Exactly.
What other languages will we be able to decode and understand?
I'm excited to find out.
It really is an exciting time to be at the forefront of this.
It is.
We're witnessing the birth of a new era in coding.
A new era.
Where humans and AI are collaborating to push the boundaries of what's possible.
It's mind-blowing.
So as we wrap up this deep dive, I want to leave our listeners with a challenge.
Okay, like it.
Think about a niche language or a specialized field that's always kind of intrigued you.
Okay.
But maybe it seemed too daunting to explore.
Right, like you didn't know where to even begin.
Exactly. But what if you had an AI assistant by your side, guiding you through the complexities, translating the jargon, helping you unlock the secrets of that domain?
That would be game-changing.
What problem could you solve? What innovation could you create?
No, could you build?
Don't let that fear of the unknown hold you back. Embrace the power of AI as a collaborative partner.
Absolutely.
And explore those uncharted territories.
The future is waiting.
The future of coding is brimming with possibilities. Go out there and discover them.
That's what we need to do.
That's a wrap on this episode of The Deep Dive.
It was a good one.
We hope you enjoyed exploring the fascinating world of LLMs and niche programming languages with us.
Absolutely.
And remember, the most important code you'll ever write is the one that unlocks your own potential.
I love that.
Keep diving.
We'll see you next time.